Solving two-step equations. Yesterday we solved one-step equation. We're going to add in one more step. And really the only difficulty, the only thing you have to learn between yesterday and today is which step to do first. Okay? So, basically, we do everything backwards. Let's start with this first step. So here's our equation. Now let's think about this. If I were to plug a number in for x, what would I do first? If I plugged in a number for x, what would I do first? No, I'm not solving. Okay, if I plug in a number for x, okay, suppose I had just this, x over 2 plus 5. If I plugged in a number for x, what would I do first? What's that? I would divide by 2. That would be my first step. And then what would I do? I would add 5. So in order to solve this equation, I'm going to do the opposite steps in the opposite order. So the last step was adding 5. What's the opposite of adding 5? Subtract 5. So that's going to be my first step. And then the next one was divide by 2. What's the opposite of dividing by 2? Multiply by 2. So in order to solve this equation, that's the steps I'm going to take. I'm going to start by subtracting 5 from each side. So on the left, the 5 is eliminated. And what do we have on the right? 6. Then my next step is to multiply both sides by 2. On the left, the 2's are eliminated. And what do we have on the right? 12. Make sense so far? What should we do now? Check it. Plug it back into the equation. Does 12 divided by 2 plus 5 equal 11? What's 12 divided by 2? Does 6 plus 5 equal 11? Yes. Okay. So 12 is the correct answer. So determine what steps you would do if you knew what x was, and then just work in reverse. Let's look at a different type of two-step equation. On the left side, we have 7x minus 4x, and that's equal to 21. Now we have two terms with an x in them. We call those like terms. Our first step should be to combine our like terms. So we want to get our x's together, which generally speaking is a bad idea, but you guys are too young to have x's, so it's okay. Okay? So we want to combine the 7x and the minus 4x. What do we get when we subtract 7x minus 4x? 3x's. Again, you guys are too young for that. Yeah. All right, now this looks like a one-step equation like we did yesterday. What do we do? Divide both sides by 3. And what do we get? X is 7. What should we do now? What should we do now? Check it. Does 7 times 7 minus 4 times 7 equal 21? What's 7 times 7? What's 4 times 7? Does 49 minus 28 equal 21? Yes. So x equals 7 is our answer. Any questions so far? Okay. Now we've got a word problem. Yay! The output of a function is 3 less than 5 times the input. Find the input when the output is 17. So the first thing we should do is write an equation for our function. So it starts with the output is. I need a variable to represent the output. What variable do you want to use to represent the output? Was that? N. Okay, N is our output. And it says the output of a function is. What does is mean? Equals. The output equals 3 less than 5 times the input. So this is what we did last chapter. We could use a little bit more review on this. Okay, we need a variable to represent our input. What are we going to use to represent our input? What's that? I. Okay, so if I is our input, we want to write 3 less than 5 times our input. What does that look like? 5i minus 3. So we start with 5i, and we want 3 less than that. Okay. Remember, when it says 3 less than something, we have to start with what we're taking 3 from. Okay. It's because we start with 5 times our input, and then we take 3 less than that. Everybody good so far? Also notice it says 3 less than, not 3 is less than. If it says is less than, then we're looking at an inequality, okay? Which we won't be doing today. It's not part of our equations. But there's a big difference. We saw that on a test. When it's is less than, that's an inequality sign like this. When it's just 3 less than, then you're looking at subtraction. Okay, don't get them mixed up. All right, so we have our equation, and it says find the input when the output is 17. Okay, I need to do something with that 17. What should I do with the 17? If it says the output is 17. Substitute it in for n. Why n? Because n represents the output. So make sure you're putting it in the right place. So we put 17 in for our output variable. Okay, so think about what we would do if we knew what I was. And let's do it in reverse. So we want to get I all by itself. We start on the outside, work our way in. What do we do first? Add 3 on both sides. Gives us 20 equals 5i. That'd be a freaky looking monster. 5 i's. Okay. The next step, we divide both sides by 5. Thank you. And we get I equals 4. What should we do now? Okay, so what happens when I put 4 in for I? What's 5 times 4? 20. What's 20 minus 3? 17. So that does give us an output of 17. We are correct. Everybody okay with that? All right, let's do one more problem. Nice big long word problem. As a scuba diver descends into deeper water, the pressure of the water on the diver's body steadily increases. The pressure at the surface of the water is 2,117 pounds per square foot. The pressure increases at a rate of 64 pounds per square foot for each foot the diver descends. Find the depth at which a diver experiences a pressure of 8,517 pounds per square foot. So let's think about this very carefully. So we need to set up an equation. It says we want to find the pressure of the water on the diver's body as he descends. So I should make sure this is up there. What is the pressure? We'll look at total pressure as our output. The total pressure on his body is our output. That's an ugly looking hay. Let's fix that. There we go. Total pressure. Okay. That means he has a certain amount of pressure on his body at the surface. They tell us that, right? At the surface, the pressure on the diver's body is 2,117 pounds per square foot. Okay, so it has a starting pressure at the top, and then it increases as it goes down. So it increases at a certain rate, and we have to multiply that by his depth. Because if it's increasing a certain amount of pounds per foot that he goes down, we need to multiply that in there. So let's plug in what we know. We don't know the pressure at to start with. Let's call that P. We don't know the total pressure that he's going to experience. This is the function that we're writing. What's the starting pressure? 2,117. What's the rate of increase? What's it going up by? 64 for each foot he goes down. So let's call that D for his depth. So we want to find when the pressure on the diver will be 8,517. Is that 8,517? Is that an output or an input? It's an output because it's a total pressure that they're giving us. It's not a depth they're giving us, it's a total pressure. Okay, and total pressure is our output, not the depth. So we're going to replace which of the variables with 8,517? P, because it's total pressure. What am I going to do first to solve this equation? Subtract 2,117. You guys are having trouble with place values today. It's 277. So what do we get when we subtract that? 6,400. What do we do next? We divide by 64. So what's his depth? 100 what? Feet. So we've been dealing with a depth of and measured in feet. What would be our last step?
Check it.
Check it. I'll let you do that on your own. There's our answer for that problem. Any questions?